Hey everyone, today we're going to learn about systems of equations and solving them using substitution. So first thing I want to do is I want to go back and remind you guys what a systems of equations are. They're just two equations, in our case just two equations with two variables. You have x and y. And remember, you can solve for x and get x by itself when it's the only variable, but when there's an x and a y with just one equation, you can't figure out what x is equal to, at least in terms of just numbers. So before, what we did last week, we drew a graph and we plotted one of them and we plotted the other line because these are both lines, and we found out where they intersected, and wherever they crossed, that was the answer, x comma y. So our solution, and that is our case with today as well, the solution to any systems of equations, no matter how you solve it, is always two numbers, an x and a y. Those x and y's are a solution because if you plug them back in to the original equation, they're the thing that makes them equal. All right? So let's talk about substitution. You guys have heard this word before, maybe in basketball or in terms of a substitute teacher. Substitution is when one thing takes the place of another. And those two things that are taking the place of the other, in math, they must be equal. Otherwise, it won't work. For example, when you have a quarter, you can substitute it out and trade it for example, 2 dimes and a nickel. Because those are exactly equal, anywhere you have a quarter, it is perfectly fine to substitute out for 2 dimes and a nickel. You might need to substitute them out to switch, to make change, to be able to pay for something where you can't pay for it with the whole nickel or for the whole quarter, but you need to pay for it with part of a quarter. So there are lots of situations where that might be helpful. Another example is a video that I hope to show you guys. If you haven't seen Indiana Jones and the Lost Ark, then here's one scene is where there is an idol sitting on top of a little pedestal, and Indiana Jones wants to switch him out for a bag of sand so he can steal the idol. Well, only if the bag of sand is exactly the same weight as the idol will this switch work. And so what happens is he takes the bag and he swaps it out. That is substitution. He's substituting the bag of sand for the idol, so the pedestal thinks that there's still an idol on it. That only works, like I said, is when they're exactly equal. So I'm going to put a box around the idol and the bag of sand, and that's what we're going to do when we get to the math. Let's, keeping those examples in mind, let's try this first problem. Okay. First of all, the first step is to find which values to substitute. In other words, what two things are you going to switch out for each other? What's going to be your idol and your bag of sand? One tip is to look for a variable that's by itself. So you see right here we've got y. Y right there is by itself. So I'm going to choose those two. That equation is going to be the things I'm going to substitute. So I'm just going to rewrite those. You don't always have to. In fact, you're fine using the original equation, but I just want to keep it a little cleaner. And I'm going to put a box around the y and around the 3x plus 3. The y is going to be kind of like my idol. I'm going to switch that out, and instead of the y, I'm going to put that in place of it, the 3x plus 3. Now, they might not look the same, but because of this equal sign in the middle here, we know they're exactly equal. Kind of like to someone who doesn't know how money works, they might say a quarter isn't the same as 2 dimes and a nickel, but you guys know they are exactly equal, and you can switch them out for each other. You can substitute. So I'm going to put a box around each of those just to show that I can substitute those. Next thing I'm going to do is I'm going to find out which value to replace in the other equation. So first I want you to write down this other equation. That's the equation right there. All right. Next thing we need to do is we need to find this variable right here in the other equation. Since it is by itself, I'm going to draw the little pedestal that the idol was sitting on, because this y is what we're going to switch out. Okay. Instead of the y, we're going to put 3x plus 3. And we're going to take the y away. So it's going to take the place exactly of where the y was. All right? So I've got my things I'm going to switch. I've got the y and the 3x plus 3. Those are the two things they're going to switch places. And I have the equation I'm going to do that in is right here. let's next do that. We're actually going to substitute. So I write the equation, but you notice instead of the y here, instead of that y, I am substituting out for this other thing. And one important thing is you always need to write your parentheses around the thing you're putting in. The reason for that is because in this first equation you have negative 2 times y. That negative 2 times y is negative 2 times everything, all of y. You're not just multiplying by a part of y, but all of y. Up here, you're multiplying by all of the thing you're switching it out for. So always put your parentheses there, and I'm going to swap out the y. Instead of the y, I'm going to put the bag of sand. I'm going to put the 3x plus 3, and I'm just going to write that right in there. That is the crux of substitution. Once you got that part down, then you're good to go because you guys know how to do the rest of this. So the next step is to solve for the variable. You can do that by distributing the negative 2. Make sure you distribute the negative 2 to both of them. A lot of people miss this right here because they think 2 times 3 is 6, and it is, but they forget about the negative. So make sure you have that negative there. Then we just have to solve for the variable. And like I said, you guys have done this, so I'm not going to spend a whole lot of time here. We can combine like terms. Then we can add 6 to both sides. Then we can divide by negative 3, and we get x equals negative 5. But we are not done yet, because remember at the beginning I said every solution has an x and a y. We found the x, now we just have to find the y. And the way we're going to find the y is we're going to substitute the x back into one of the other equations. So let's draw our box around the x and the negative 5. This is now the two things are equal, so we can switch them anytime we see an x instead of x. Since we know it has to be negative 5 in this situation, we can put negative 5 instead. And I'm going to take this equation from the very top up here, and I'm going to put that right here. And notice, instead of the x, I'm putting the parentheses, because I want to substitute instead of the x, I'm going to substitute out the x and put in a negative 5 instead. So Indiana Jones style, we're going to switch those, and we put a negative 5 in there. The swap works, and we can just solve for y now. 3 times negative 5 is negative 15. Add those, you get y equals negative 12. So our solution is, and our answer is always in the form of x comma y, negative 5 comma negative 12. All right. I hope you learned something from this video. Please try the practice problems on the back right away and refer back to this video if you get stuck on them. Again, hopefully you can find someone else who can help you out with it if the video isn't helpful enough. And if all else fails, you can raise your hand and call me over. Thank you very much.